Okay, hello everyone. Today we'll be talking about theoretical yield and how to find theoretical yield, and we'll be going through some examples so that way we can learn how to find the theoretical yield. So what is a theoretical yield? It is the amount of product resulting from a perfect or theoretical chemical reaction and is not the same as the amount you get from a reaction performed in the lab. It can be expressed in grams or in moles and is calculated using the limiting reactant. So how do we find the theoretical yield? So it can be broken down into two really simple steps. The first is to find the limiting reactant using the mole ratio, and the second is to convert from moles to grams. So let's do an example. So we have 1 mole of aluminum oxide plus 2 moles of sodium hydroxide will make 2 moles of sodium aluminate and 1 mole of water. So we have 0.467 moles of aluminum oxide and 1.19 moles of sodium hydroxide in this particular setup. So the first step is to find the limiting reactant. We are going to do this by multiplying the moles of each reactant by their respective mole ratio, which is basically the ratio of reactants to the products. So for the first one, we have 0.467 moles of aluminum oxide. We're going to multiply that times its mole ratio, so there's 1 mole of aluminum oxide per 2 moles of sodium aluminate. And that is going to create 0.934 moles of sodium aluminate, and that is the product that you're going to get when you add 0.467 moles of aluminum oxide. And so now we also have 1.19 moles of sodium hydroxide. We're going to multiply that times their mole ratio of 2 moles of sodium hydroxide over 2 moles of sodium aluminate. And that's going to give us 1.19 moles of sodium aluminate. So the limiting reactant is going to be aluminum oxide because we're going to run out of that faster. And so we're going to create only 0.934 moles of sodium aluminate. The next step is to convert the moles to grams using the formula weight. So the formula weight for sodium aluminate is 81.97 grams per mole. So we're going to multiply 0.934 moles of sodium aluminate times 81.97 grams per mole of sodium aluminate, and we're going to get 76.56 grams of sodium aluminate as our final theoretical yield. So always remember that the actual yield is going to be a little bit less than the theoretical yield because no chemical reaction is going to happen perfectly, even in the most controlled lab settings. So not all of the reactant may be used up during the chemical reaction, and so the actual yield will be a little bit less than the theoretical yield, but the theoretical yield does give you a good idea of what to expect. And this concludes my talk on theoretical yield. Thank you guys for listening to my presentation, and everyone have a great day.